right, now let's continue our discussion. So now I'm going to show you how to debug applications using Android Studio. I'm going to show you two basic techniques. The first one is breakpoints, okay? The second one is um, um, log messages, okay? So I'm going to show you how to do that using Android Studio directly. So say if I wanted to set a breakpoint in this file, okay, iTunes preview fragment at this line, okay, at line 52, for example. So you can see that once I click on the right hand side of the line number, which is 52, okay, Android Studio is going to show a red dot over here, okay? And that line is also highlighted in red, okay? So that means you have successfully set up a breakpoint at this line, okay? At this line in this file. So whenever the application during its execution, when the app hits this line, Android Studio is gonna pause your app, okay, so that you have a chance to observe the states of all the objects visible at this line. Okay, so let's try it. So let's hit the green button over here, and this is for debugging again. Okay, so you can see the Gradle's building. Oh, the process app is running. Okay, let's terminate the current application. So now you can see Android Studio is connecting to the emulator, and now the app is running. Okay, so let's arbitrarily select one of the songs listed on the screen. So this time I'm gonna go with "In Jesus' Name." Okay, so now you can see that once the execution hits this line, Android Studio is gonna pause the application, and you can see it also automatically brings up the debug tool window. And in the debug tool window, the left-hand side is the call stack. Okay, the call stack. You can see who calls who calls this function. Okay, the order of the function calls basically, and you can see all the objects and their states visible at this line. Okay, say this inflator object. Okay, so you can see all the values of its properties over here. Okay, so by observing the properties of objects, and you can figure out what's going on in the code and find the problems in your code. Okay, so it's very simple. So now how can we cancel a breakpoint? It's very simple. Simply click at the right hand side of the line number again, then it's going to cancel the breakpoint. And once the execution hits the breakpoint again, it's going to pause. And you can, so what to do next? Well, you can, stop the application and rerun it again. Or alternatively, if this is where the problem is, you can resume the execution by going to run debugging actions, and you can choose to resume the program, resume the app, or you can choose to step over or step into. Step over and step into are two commonly used functions when debugging. So step over means, if the line at the breakpoint, okay, is a function, okay, and step over, if you choose to do step over, then Android Studio is going to invoke the function, execute the function directly, and move to the next line. And in contrast, step into means Android Studio is going to dive into the function, okay, so that you can examine and debug the function. Okay, so that's the difference between step over and step into. And because they are used very often, so you may want to memorize the hotkeys for step over, step into, and probably memorize the hotkeys for resume programs as well. Okay, so these three are used very often. Okay, so memorize the keywords can save you some time when debugging. Okay, so that's the first technique. Okay, so now I'm going to show you the second one. The second debugging technique is also very simple. And that is, I'm going to show you how to send debugging messages to the logcat tool window. Okay, so this is the logcat tool window. And now, the app has been terminated or stopped, right? So you can see the emulator has gone back to the home screen now. So here I am going to let's say I'm going to add a debugging information or debugging message over here. So how can we, send the debug message to the logcat window? It's very simple. We simply use the logcat. We make use of the log class. Okay, so the log class provides several useful, logging functions. Okay, and each of them correspond to one of the debugging priorities. Okay, so if you recall, there are several priorities such as verbals. Okay, verbals, debug, info, information only, warning messages or error messages, and the search messages. Okay, so if you want to send the information only messages to the logcat window, we can use the I function. Okay, so all the logging functions has requires two parameters. The first one is a tag. The second one is the message body. Okay, so I'm going to type. I'm going to use maybe my name, okay, as the tag. Okay, and I'm going to send the title for the song the user selected to the logcat window. Okay. Okay, so now let's see if we can see this information or see this message in the logcat window. So now you can see, on the status bar, you can see that Gradle's building, and now it's installing the application, and now the app has been launched in the emulator. So I'm going to set a breakpoint again over here. Maybe not this one. Okay. Oh, and now suppose I hit this line. I select one of the songs. So you can see that the program's paused, and now I'm going to switch to the logcat window, and now why there's okay, sorry. The logcat window is now connected to the my physical phone, which is an mistake. I'm going to change it to the emulator. Okay, so now you can see the messages, output by the emulator. Okay, you can see that the message that I sent is right the last line. Okay, it's right at the bottom. Okay, so last line. Here's the tag. Okay, which is my name, and this is the message body. Okay, the song title, Till You Can't. All right, okay. So if you cannot find your messages in the logcat window, it's probably buried in the flood of messages. Okay, so in that case, you can try to filter the messages using this drop box. Okay, so so because the priority that I chose is information only, so I'm going to choose info over here. Okay. So by choosing info from the Dropbox, the logcat window is going to show information only messages, okay? And if it's not enough, you can use this box to search for your messages, okay? You can search using the tag, okay? So now it's so now the logcat window only shows the message that I sent. All right, okay, so So got it? Okay, so debugging is very simple in Android Studio, okay? And again, because there are many students in the class and I cannot debug for everyone, so don't expect me to debug your homework assignments or final projects. Of course, I can provide pointers, but I'm not going to debug for you because my time is very limited. Okay, sorry about that. Okay, now we are done with debugging. So now I think let's go back to the slide. Okay. So now the next topic is model view controller pattern, and model view controller pattern is sometimes called the model view presenter pattern. Okay. So excuse me. So the model view controller pattern was introduced by this guy. I don't know how to pronounce his name. So this name is obviously not an English name. Okay, so this guy he was a small talk developer at the Xerox Palo Alto Research Center in 1979. And so this design pattern helps to decouple data access and business logic from the manner in which it is displayed to the user. So to be more specific, this pattern divides the classes in our code or in our app into three camps. Okay, the first one is the model camp. The second one is the controller camp. The third one is the view camp. So the model presents the data and the business rules that govern access to and updates the data of your application, okay? And a model should be independent of the user interface so that the model can be reused for different user interfaces, okay, for in apps with different user interfaces. So you might be wondering what model really means. Well, suppose you are developing a car game, okay, a car game app. So the model would, consist the cars, the poker cars, as well as the game rules. Okay, so that's the model. Okay, and the model should be independent from their presentations or how they are displayed on the screen. Okay. And views, the next one, controllers. So basically controllers translates the user's interactions with the view into actions that the model will perform, okay? And the controller is also responsible for updating the user interface when the model changes. So to be short, controller basically uses classes in the view camp to display the model, okay, the data to the user on the screen. Okay, so controller is a middleman between the model and the view. Okay, and the view, obviously, views are the minions that the controller use to render the contents of the model. In other words, it specifies exactly how the model should be presented. Okay, and the view also interact with the user directly, and whenever something happens, it's going to notify the controller, and the controller will modify or update the data model accordingly. And likewise, whenever the model is changed, the controller is also going to be notified as well, and the controller is going to update the user interface using the classes in the view camp, okay, accordingly. So that's the model view controller pattern. So why are we using model view controller pattern? Well, there are two major advantages when using model view controller pattern. Well, the first one is MVC pattern allows simultaneous development of the model as well as the views. Okay, so this means the backend developers can design the data structure without requiring the user interface to be completed. So likewise, the front-end developers are able to design and test the layout, in other words, how the app looks like on the screen, okay, prior the data structure being available to them, okay? So the back end and the front end can be developed in parallel, okay? So that's one of the biggest benefits of using the model view controller pattern. The second advantage is code reuse, okay? So recall that the classes in the model camp and the classes in the view camp, they are independent, okay, of each other, okay? So that means the same UI or similar UI for one application can be refactored for another application with different data, okay? And likewise, the same data can be adapted to different UIs, okay? So for example, suppose you designed something called list view to display a list of items, okay? And because this view, okay, this view is independent of the data. So you can use this list view in one app to show the list of the news, okay, in case you are developing a news reader. And the same list view can be reused in another app to display a list of to-do items or a list of emails in a different application, okay? So UIs, since it's independent of the data, UIs can be reused from on the same UI for one application can be refactored for another application with different data, okay? And similarly, since data, the model is independent of the user interface, the same data can be adapted to different UIs. So for example, suppose you want your application to be able to run on phone and on Android pad, okay? Obviously, it is obviously doable, okay? However, because, Android pad or pad devices usually have a much bigger screen than phones. So you may want to display more information on the screen when your app is running on tab devices, right? Okay. And because model is independent of the view, we can reuse the model classes for applications that is particularly or specifically designed for phones and reuse it on applications that are particularly or specifically designed for tab, okay? So these are the two biggest advantages of using the model view controller pattern. So the next topic is views. Okay, so you probably know what views are. Okay, so basically everything you see on the screen, either on phone or on tablets, everything you see on the screen is a view. Okay, so in Android SDK, the view class represents the basic building block for all UI components. So everything is a view. A button is a view, an image is a view, a label is a view, everything is a view, okay? So everything you see on the screen is a subclass of the view class, basically. And the views can have properties. For example, they can have different colors, different sizes, in other words, dimensions, and they can be placed at different positions on the screens. And views can receive focus. Okay, they can, in other words, they can be selected to receive user inputs, and they can be interactive with the user. They can respond to user clicks or users' hand gestures, and they may be visible or not on the screen, and they can have relationships to other views. Okay, so one view can have relationships to other views nearby. So we'll talk more about this later. Okay. So the Android SDK provides awful lot different views, okay, for different purposes. For example, the SDK contains buttons, obviously. It also has edit text so that we can collect user input from the user, okay, or text. We can collect text data from the user. The SDK also contains seek bar, checkbox, radio buttons, switch buttons, so on and so forth, and even image views. So these things, they are subclasses of the view class, okay? However, occasionally we may not able to find a view in the SDK that satisfies our need, okay? Suppose you are developing a financial application, okay, and you want to show a pie chart that summarizes the percentage or the amount of money a user spend on different categories such as food or traffic or investments, so on and so forth. And because the pie chart is dynamic, okay, you cannot simply draw a pie chart and put it in your app and put it on the screen. Okay, so the pie chart varies from month to month. Okay, so and unfortunately, as far as I know, there's no pie chart. There's no such view. There's no such view class in the Android SDK. So in case you really want to plot pie chart, okay, then you are gonna have to create a custom view. And if time permits, of course, I'm going to show you how to create a custom view. Custom view class actually later in the semester. Okay, now there are three ways to create views and put them on the screen. The first two ways are we can always use the layout editor in the provided by the Android Studio. Okay, so the first one we can let me open a layout file. Okay. So the first method over here simply says graphically within Android Studio. This means the design mode of the layout editor. Okay, so you can see there's a palette over here. I'm not sure why Google called it palette, but the palette contains the views provided, okay, in the SDK. Okay, so once you have chosen one view, okay, you can drag it from the palette and put them onto into the layout file, okay, and you can put it anywhere you want, okay, and so you can see that I have an image view over here, okay, and by selecting a view in the layout editor, so we can change its or modify its properties, okay, like its width, its height, and we can also give it an ID so that we can access this view in our code. And we can also specify other properties like the background color, so on and so forth. Okay. And another way, the second way is that we can edit the XML directly. So how do we do that? We can simply switch to the code mode. Okay, code mode means we're gonna edit the layout XML file directly inside the Android Studio, and you can see this is the image view. Okay, that we have seen in the design mode. And we can, modify the layout directly using XML, and we can modify the property of each view in XML as well, as you can see on the screen. Okay, it's very simple. And the third way is also the more difficult way is we can create a view in our code and put it on the screen at the runtime. Okay, so when you are creating a view, okay, suppose you're creating a text view, for example, as shown on the slide. When creating a view, you're gonna need a context. Okay, and what is context? Basically, a context is simply a handle to the system providing services like, resolving resources, obtaining access to databases, preferences, so on and so forth, okay? And anyway, when you are creating a view, you need to give it a context. And usually we're creating, we normally create views in an activity, and an activity is its own context, okay? So that's why we usually, pass the activity as the context, when creating views. Okay, so once views is created, once a view object is created, you can change or modify its properties using the dot notation, such as shown here. Okay, so once you are done, you can put it onto the screen by inserting into and layout, okay, on the screen. And it's very simple. We're gonna do this maybe next week, okay. Okay, if you recall, I mentioned that a view can have relationships with other views. So what does that mean? Okay, so this means, well, before I explain the concept, well, I need to introduce another thing, which is a view group. Okay, a view group is basically a view group is also a view. What makes it special is that a view group can contain other subviews. Okay, again, a view group is simply a view, but it can contain other subviews. And most often, a view group is invisible to the user on the screen, okay? Uh, uh, but why do we need view groups then? View groups help us to lay out or to determine the positions of subviews contained within it, okay? And there are two common view groups, such as a recycler view and a linear view. We'll talk more about these two view groups later in the semester, okay? So a view group not only can contain other subviews, it can also contain other view groups, okay? So the views in your app on the screen, is going to form a view hierarchy like this, okay? So in this sample, you can see on the top, it is a view group, and this view group contains a second view group and other two subviews. And the second view group contains three other subviews. Okay, so this forms a view hierarchy. And one thing to keep in mind is that when you are designing the layout for your app, try to make the view hierarchy as flat as possible. Okay, if the view hierarchy is very deep, it's going to be a very inefficient. Okay, your app is going to be very slow. Okay, because updating a view hierarchy or drawing a view hierarchy, a deep view hierarchy on the screen is very slow. Okay, and so here's an example of a view hierarchy and a screen layout. Okay, so this is what you are going to see on the screen, but in reality, to make an app look like this, you are gonna have to have a linear layout, okay, on the top, in the view hierarchy. And then you put the other things inside the linear layout. The first one is button, okay, which is the text button on the top over here. And the next one is text view, okay, which shows the 0 with yellow background color, okay, over here. And the next view is going to be a second button, which is the count button over here, okay. So this is what you are going to see on the screen, and this is what the layout really looks like, okay. And by the way, a linear layout, again, it is a view group. And a linear layout is a very useful and a very commonly used layout. A linear layout is a very simple layout. So whatever you put inside the linear layout is going to arrange its position or linearly in a linear fashion, either top down or from left to right. Okay, so that's why it is called the linear layout. And so how can we see the view hierarchy in Android Studio? Well, if you noticed, let me switch back to the design mode of the layout editor. So you can see there's something we call component tree over here. And here you can see the view hierarchy, okay? So based on the view component, you can see that this layout, there's a linear layout at the top, okay? And I there's a view and image view and text view and anchor view inside the linear layout, okay, from top to down, from the top to bottom, okay? So now back to slide. The Android SDK provides many useful layouts. Linear layouts is one of them. So I have explained linear layout to you, right? And another commonly used layout is relative layouts. So relative layout, a relative layout arranges its subview according to the relative positions, okay, you specified for the subviews, okay? And the grid layout simply arranges, subviews as a table, and grid layout is scrollable, and a table layout is just like a grid layout, but it's not scrollable. And another very useful and powerful layout is called constraint layout. Constraint layout is a very complicated layout. We may need 1 week to, or a few hours to talk about linear layouts, and I'll definitely do so later in the semester. So basically, linear layout is going to arrange its subviews according to the constraints you put on the subviews, okay? So for example, you can specify a constraint to align the left boundaries for these two text views, and you can also specify a constraint on the distance between them, so on and so forth. So basically, based on the constraints given, okay, by you, a constraint layout is going to determine the subviews automatically for you, okay? And yet another layout is frame layout. And frame layout it's a very simple layout. It acts like a stack, okay? So whatever you put into the frame layout is going to stack them, from bottom to top, okay? Of course, top views can cover some areas of the view sits at the bottom. Okay, so that's the frame layout, very simple. Okay, okay, layout editor. I've also shown you this. Okay, and similar to views, we can also create layouts in code. And this slide simply shows how to create a layout objects in code, but we rarely do this. Okay, so we usually only create views in code. We usually, okay, we rarely create layout objects in code. But anyway, this slide shows you how to do it. Okay, and since we're not there yet, I'm not going to discuss the details with you. Okay, event handling. Okay, recall that views can be interactive. Okay, they can receive users' input like click events, tap events, hand gestures, so on and so forth. So how do we set up a event handler with a view? There are two ways to set up for example, click handler with a button. The first way is we can set up the click handler in XML. Okay, suppose let me show you directly in Android Studio. So preview fragment. Okay, let me go to the layout file. Fragment 19 preview, design mode. So I'm going to add a button, okay, at the bottom of the layout. Okay, it is a linear layout, so it's going to sit. Oh, it's over here. This is the buttons over here. Okay, at the bottom. Okay, so there are two ways to set up a a click handler for this button. The first one is we need to go to the code mode in the layout editor. Okay, and here we can specify a property that is onClick. Okay, onClick, and here we can specify the function. Okay, that is going to handle the click event for this button. So say I'm going to call the function on button click. Okay, and obviously I don't have this function in my code. Okay, and in this case, I'm going to I already have this function in my code. Let me check. So I choose the preview fragment. No, I don't think I have this function in my code. Or anyway, go back to the layout file. Okay, to define this function in code, you can press and hold Option key and enter. Okay, and it's going to show you a menu. Okay, you can see the second option on the menu is create on-click event handler. Okay, and you can choose where to put the code. Okay, I'm going to put it inside the preview activity. Okay. So now back to preview activity, you can see that on click handler, the function is going to be defined over here at the bottom. Okay, so that's one way to set up a click event handler for buttons or views. Another way is, let me delete what I just added first, okay? Just in case I forgot to do so. I'm going to delete the button as well. So a second way is we can set up the click handler for buttons or views in code as well. So in case you want to do this, oh, by the way, let me add the button back. In case you want to do this, you need to be sure to assign an ID to the button or the view, okay? And now you can see the ID for this button that I just added is ID/button. Okay, so now I'm going to go back to the iTunes list fragment. Okay, I'm going to set up a click handle for that button in code. So to do so, we need to get a reference or a pointer to the button first. So that can be done by using the find view by ID function. Oh, I'm using data binding, so that I cannot do that. I have not touched this code for a long time, so I kind of forgot where it is. Let me do it in preview activity instead. Okay, so let me do it in onCreate. Okay. So usually we can retrieve the reference to a view or a button on screen using the find view by ID function, and it is a button. Okay, so to reference the view in a layout file, we use this ID. So the ID should be inside the R objects, r.id.button. Okay, so this is how we retrieve a reference to a view in a layout file. And you can see the button class is highlighted in red because we haven't imported this class yet. And to do so, if you're using Windows, you can press and hold the Alt key and press enter. And if you're using Mac, you can press and hold the Option key and press enter. Okay, so it's going to import the button class into this file. So now, once we have obtained the reference to the button object, we can set up a click event handler using the set on-click handler function. And there are two versions. The first one requires a object that implements the view on-click event on-click handler interface. So here I'm going to use the object expression introduced last week. Okay, so this view object need to implement view.onClickListener interface. Okay, And you can see Android Studio automatically highlights this anonymous object, okay? The reason being that we declared that this object is going to implement this interface, but nothing is here. Okay, so to do so, to implement the interface, again, we can press and hold the Option key and press Enter if you are using Mac. And if you are using Windows, simply press and hold the Alt key, the Alt key, and then press Enter, okay? And it's going to show you this menu and simply select the first option, Implement Members, okay? So now you can do whatever you like when the user clicks the button inside this function, unclick, okay? So another version of this set on click listener is instead of using the object expression, you can also give it a lambda expression as the event handler, okay? So we can say set on click listener, okay? So this, you can see that this is a different version, okay? And in this version, we can pass it a lambda expression instead of an anonymous object implementing the on-click listener interface. So the second version is much simpler, okay? So we can do whatever you like when the user clicks the button. Okay, so very simple. Okay, so what's next? Okay, resources. So all the resources, they are placed inside the RES folder, and depending on the type of resources, they can be placed inside different, stuff folder. Usually images and icons, they are placed under the durable folder, and layout files, they are placed under the layout folder, and the values or constants such as colors, dimensions, strings, and styles, they are placed under the values subfolder, okay, in different files, of course. And to reference the resources, of course, we can use the R object, okay? For example, if you would like to reference a string, you can say r.string dot the ID for the string resource, okay? And okay, I think that's enough for talking. So now there's a second lab. Sorry, that's the third lab, not the second lab. So here's the second lab. So this lab is called the Basic App Anatomy. So in this lab, you'll learn how to edit an app's layout file, and you'll also learn how to create an app with interactive behavior. In other words, setting up, click handler for a button, just like I did, okay? Just like I showed you earlier in the lecture. And you will also learn a lot of new terminologies, okay? So 100 minutes of lecturing plus 2 lab assignments, I think that's enough for the week, okay? So have fun, and in case you have any questions, always feel free to send me an email or give me a call. All right, so I will talk to you later. Have fun.